Assalamualaikum and good morning semua. Okay, so today we will continue with some applications of integration. Okay, so we have areas under and between curves. Okay, mean and RM root mean square values. Okay, volumes of solids of revolution. Okay, and centroids. Okay, so now we go for areas under and between curves. Okay. So here we have a curve, okay. So areas under curves is positive, okay. And then areas above curve will be negative, and again above curve, below curve is positive, okay. So we start the the upper limit from right, okay, and then the lower limit to the left. Okay, so this one is, okay, integration of fx dx, okay, the curve between a and b. Okay, so this one between a and b. Okay, and then we have integration f of x, okay, from b to c. Okay, from b to c, so it is negative. Okay, and then fx, integration of fx from C to D. Okay, so this is positive because it is under the curves. Okay. Okay, so we have an example here. So determine the area between the curve. Okay, y equal to x cubed minus 2x squared minus 8x. Okay, and between the curve and the x-axis. Okay, so notice that this part here we have positive value, okay, positive, it will be positive, okay, okay, and then we have areas above the curve, so this one will be negative, okay, and then this limit for this curve on the left side will be from -2 to 0, and then 0 to 4. Okay, so now we will write the integration for the shaded area. Okay, so we have, okay, we have, okay, maybe I put it, okay, so x cube, okay, minus 2x squared minus 8x. Okay, this one is positive for the first part from -2 to 0. Okay, and then minus because the second part is above the curve. Okay, x cubed minus 2x squared minus 8x. Okay, don't forget the x here. Okay. The x, okay, from 0 to 4. Okay, so then now we have to integrate. Okay, so this one will be x to the power of 4, 4 minus 2x cubed over 3, okay, negative 8x squared over 2. Okay, so simplify, okay. So it become x to the power of 4 or negative, okay, 2, 3x cubed minus 4x squared, okay. And then don't forget to apply the limit, which is -2 to 0, okay, minus, okay, the same thing, minus 2/3 x cubed minus 4x2 squared, from 0 to 4. Okay, so now we just put the value. Okay, so this one will be, okay, everything is 0. Okay, so 0 minus, okay, -2 or 4/4 minus 2, 3, -2 minus 4, 2 squared. Okay, and then don't forget, this is the first one. Okay, so you will get this one equal to 6 2/3. Okay, so and then for this one you will get 4 4/4, okay, minus 2/3, 4 to the power of 3 minus 4 squared. Okay, and then minus 0. So this one we will get negative 42 2/3. Okay, so now 6 2/3 minus negative 42 2/3. So then we will get 49 1/3 square units. Okay, so that is the shaded area between the curve and x-axis. Okay. Okay, so next we will cover on mean and root mean square values. Okay, so the formula is this one. Okay, so if we want to calculate mean value, okay, so it will be 1/b minus a, which is a is the lower limit and b is the upper limit. Okay, so integration y dx. Okay, for RMS value, so it will be root mean square, the whole things, and then okay, the same 1/b minus a, which is a is the lower limit and b is the upper limit, and then integrate y squared dx. Okay, so the difference here is y is squared, and then we square root everything. Okay, so let's see some example. Okay, so here we have to determine the mean value of function. Okay, f of x equal to, okay, x squared, okay, minus 5x. Okay, and then we have from x equal to 1 to x equal to 4. Okay, okay, so the mean value, okay, the formula is 1/b minus a, which is, okay, b is 4 minus a. Okay, then 1 4, and then y x squared minus 5x, okay, dx. Okay, so this one we just integrate this one. Okay, so right back, so this one x to the power of 3/3 minus 5x squared over 2. Okay, and then 1 to 4. Okay, so then we just 1 over 3. Okay. Okay, so this one is, okay, we substitute x with 4. So 4 to the power of 3 over 3 minus 5, 4 squared over 2. Okay, and then minus, now x we substitute with 1. Okay, so 1 to the power of 3 over 4 minus 5, 1 squared over 2. Okay, so we will get 1 over 3. Okay, and then 64 over 3 minus 40. Okay, and then minus 1 over, okay, so 1 over 3 over 3 minus 5 over 2. So it is equal to negative 33 over 2. Okay, so the mean value is equal to negative 33 over 2. Okay, and therefore this one we have to determine the root mean square value of the function f of x equal to x squared minus 5. Okay, from x to 1 to equal to 1 to x equal to 3. Okay, so for root mean square value, okay, it is, okay, for the short form, we just call it Rm SV. Okay, 1 over, okay, b minus a, which is 3 minus 1. Okay, and then integration 1 to 3. Okay, y is x squared minus 5. Okay, then we have to square dx. Okay, so we have to, okay, so this one 1 over 2. Okay, so x to the power of 3 over 3 minus 5x. Okay, minus 5x. Oh, no, sorry, this one. What we have to do is we have to square everything first. Okay, so it will be like state integration. Okay, 3 to 1. Okay, and then 1 to 3, sorry, x squared. Okay, minus 5. Okay, expand it. Okay, x squared minus 5. Okay, dx. So this one will become, okay, 1 over 2, 1, 2, 3. Okay, this one will become x to the power of 4. Okay, minus 10x squared and then plus 25. Okay, now we can integrate this one. Okay, so it will become 1 over 2. Okay, x to the power of 5 over 5. Okay, minus 10x to the power of 3 over 3 plus 25x. Okay, from 1 to 3. Okay, so now we can substitute the value of x into t first. Okay, and then minus x equal to 1. Okay, so this one we will have 1 over 2 outside. Okay, and then 3 to the power of 5, okay, over 5 minus 10, 3 cube over 3 plus 25, 3, okay, and then minus 1 to the power of 5 over 5 minus 10, 1 cube over 3 plus 25, 1. Okay, so we have 1 over 2, okay, bracket 2 for 3 over 5 minus 270 over 3 plus 75, okay, minus 1 over 5, okay, minus 10 over 3 plus 25, okay. So finally the RMSB is equal to 176 over 30, okay. Okay, so Assalamualaikum and good morning everyone. Okay, so we will cover on volumes of solids of revolution. Okay, so the volume of revolution V, okay, obtained by rotating area A through one revolution about x-axis. Okay, so this is the formula. V, volume of solids, okay, of revolution is equal to integration by y squared dx, okay, from lower limit A to upper limit B, okay. So this is dx because we rotate about x-axis, okay. So let's see some example, okay. So given here is the curve y equal to x squared plus 4, okay, is rotated one revolution about x-axis, okay, between limits x equal to 1 and x equal to 4. Okay, so determine the volume of solid of revolution produced. Okay, so this is the curve, and this is the area that is given from x to 1, okay, to x equal to 4. Okay, so the formula will be to find the volume is, okay, so it is V equal to, okay, lower limit 1 to upper limit 4, okay, and then pi y squared dx, okay, so right again 1 to 4 pi, okay, y is x square plus 4, okay, then square dx, okay, so we have to expand the y first, okay, so we will have 4 to 1, okay, pi. Actually, you can put outside pi. Okay, never mind. Okay, so expand x square plus 4 and then x square plus 4. Okay, so put pi outside 1 and 4. So we have okay, x to the power of 4. Okay, plus 8x square plus 16 dx. Okay. Okay, then okay, we have just now is 4, 1, okay, pi outside x to the power of 4 plus 8x squared plus 16 dx. Okay, so integrate this one. Okay, we will have x to the power of 5 over 5 plus 8x to the power of 3 over 3 plus 16x. Okay, and then from 1 to 4. Okay, so we have to replace, okay, with 4 first. Okay, with 4 to the power of 5 over 5 plus 8, 4 to the power of 3 over 3 plus 16, 4. Okay. And then minus, okay, 1 to the power of 5 over 5 plus 8, 1 to the power of 3 over 3 plus 16, and bracket 1. Okay, so we will have the pi. Okay, this one, 204.8, okay, plus 170.67, okay, 7 plus 64 minus, okay, 0.2, okay, plus 2.67 plus 16, okay. So now we have 422.2, sorry, 0.6 pi cubic units. Okay. So then, so that is the volume. Okay. Now we come to centroids. Okay. So let's say we have area A here. Okay. This is a curve, and this is the area under the curve, which is area A. So now we want to find the centroid. Okay, the centroid is the center of A. So to find the x, okay, from the origin, okay, to the centroid, so this is the formula given, okay. And then to find y, okay, distance of y from 0 to the centroid, okay, this is the given formula, okay. So just use this formula if you want to find the centroid of area. Okay, so let's see some example here. Okay, so we have to determine the coordinates of the centroid of the area lying between the curve y equal to 5x minus x squared and the x-axis. Okay, so this is the area, and then we have to find the centroid. Okay, so then we just have to use the formula. Okay, first we find the x. Okay, so x here is equal to, okay, this one, okay, integration xy dx a to b, okay, and divided by integration y dx from a to b, okay. So b here is 5, okay, b is 5, a is 0, okay, and then so it is from 0 to 5, okay, xy dx over the same 0 to 5, down here is y dx, okay. So it will be 0 to 5 x, okay, and then y, which is 5x minus x squared dx, okay, over 0 to 5 on dy, so 5x minus x squared dx, okay. So we have to integrate this one, okay. So it will become, okay, above here it will be 0 to 5, okay, 5x squared minus x cubed dx, okay. This one 5x minus x squared dx. Okay. So then we just integrate. So it become 5x to the power of 3 over 5 minus x to the power of 4 over 4. Okay. This one for the above part. Okay. Then for the lower part here is 5x to the power of 2 over 2 minus x cubed over 3. Okay, so 0 to 5 as well. Okay, so then we will get this one 6 to 5 over 3 minus 6 to 5 over 4. Okay, 1 to 5 over, oh, okay, I think we have to, okay, since 0 minus 0 is 0, right? Okay, 0 is 0, okay. If we replace 0, it will be 0. Okay, so no need to write 0 here. Okay, then 1 to 5 over 2, okay, minus 1 to 5 over 3. Okay, so we will get 6 to 5 over 12. Okay, and then over 1 to 5 over 6. Okay, so we just multiply cross. Okay, something like that. 12. Okay, multiply with 6 over 1 to 5. Okay, so we will get 5 over 2 or 2.5. Okay, so the x centroid, okay, will be 2.5. Okay, and then next we want to find the coordinate of y centroid. Okay, so y centroid is 1 over 2. Okay, this one. Okay, this is the formula. Okay, and the above one we have 1 over 2 and then y squared. Okay, so the below here is similar. Okay, with a centroid. Okay, 1 over 2. Okay, from 0 to 5. Okay, and then y squared dx. Okay, over 0 to 5 y dx. Okay, so 1 over 2, 0 to 5. Okay, y is 5x minus x squared. Okay, and then squared dx over 0 to 5 integrate 5x minus x squared, okay, dx. So then we have to expand the above part. Okay, so it will be equal to 1 over 2. Okay, so this one we will have 25x squared minus 10x 5x 5x. Okay, so this one will be to the power of 3. Okay, plus x to the power of 4 dx. Okay, since the above below part here, we have counted before this, which is similar, which is we get this one, okay, 125 over 6. Okay, it's just the same. So we take the value, which is 125 over 6. 125 over 6. Okay, so now 1 over 2. So integrate this one, we will have 25x to the power of 3. Maybe a little bit lower. So we have, okay, 1 over 2, okay, 25x to the power of 3 over 3 minus 10x to the power of 4 over 4 plus x to the power of 5 over 5 from 0 to 5 over 1 to 5 over 6. Okay, so we just replace x with 5. Okay, so we have 1 over 2, okay, 25, and then 5 to the power of 3 over 3 minus 10, 5 to the power of 4 over 4 plus 5 to the power of 5 over 5. Okay, since 0 is 0, okay, so it's okay, just put 0. And then 125 over 6. Okay, so we get 1 over 2. Okay, 25 over 3, 125. Okay, minus 6250 over 4 plus 625. Okay, over 125 over 6. So it is equal to 0.5. Okay, so here y centroids is equal to 2.5. Okay, so that's all. We have finished the syllabus. Okay, so thank you and Assalamualaikum.